Encoded.
Okay, I'm gonna grab
storage
some water before we
introduction.
start.
Okay.
Oh, I need to heat up my coffee. One sec.
Peak.
Pick.
Pika.
Okay.
Okay, should we start or are we waiting for more people?
I think this is probably the amount of people we're gonna have.
All right. Barbon's best resource pack. All right, so we can start off. So I'm Crazy Chris. I've been doing TMC for like 2 years, maybe, mostly past half a year, developing my encoded storage mostly. I got into storage tech by Cubic Meter actually, but with his Dolphin storage, that was my first introduction to that stuff. And after that, I was like hooked a bit. I was like looking what is it all about, and then boom, SciCraft MS dropped. Okay, who was changing slides? I don't know. That was not me. Yeah, so basically I got into encoded tech because of SciCraft MS. I was really amazed by how remote bulk works. And yeah, I wanted to do the same basically, but I didn't know what is what. And like I looked at the wiring, I was trying to figure out how does it even work. And sometime after that, RedWave MS dropped, and we got much better, much more modern example of remote bulk. So yeah, after that, I basically decided that I want to make my own, and I hated setting up filters so much that I was like, yeah, I'm not going to do hybrid storage. It's gonna be fully encoded because filters are just atrocious to set up. So yeah, that's how we ended up here. So, okay, how do I do next slide? I have no idea.
Just click on the edge, Chris.
On what?
The right side.
Oh my god, okay, it works. Amazing. Yeah,
Oh.
okay, so As of table of contents, we'll start talking about a code. I'm not sure if everybody here is familiar with how encoding works, or even how to read binary. What is it? How to convert binary to hex, or what even is a DMAX. We will talk a bit about the encoder and how do we derive code from there. Then about the most important part of the whole storage, like priority manager, probably. Without it, nothing would work properly. Then I will try to explain how to sort items into chest file using code boxes. Maybe talk about some alternatives, code boxes themselves, and at the end about remote bulk, all the logic, everything about it. So binary code is basically like it's ones and zeros. It's a representation of any character in binary by the powers of 2. So like if we have 10-bit code over here, if we start from the right side is from 2 to the power of 0. It's either 1 or 0. 2 to the power of 1 is 2 or 0, and so on. So usually if you would learn about binary in school, they would make you write tables like over here. This is a 2-bit table, so 0 is represented by 2 zeros, 1 is 0, 1. Number 2 is 1 and 0 because this is 2 to the power of 1 and to the power of 0, so it's 1 and 0. And for, it should be 3. Never mind. Yeah. So if you want to convert to hex is basically a full range of 4 digits in binary from 1 to 15. Like in computer science, you would go from 0 to 9, and then you would use letters from A to F. But we are just converting it to signal strength, so it's from 0 to 15. Usually done by composters and subtracting from comparators. So if we talk about demuxing, to me, I struggled to grasp this concept. There was like zero explanation about it. But what it usually means, for me at least, is taking part of the code and doing something else with it. So if we have like 10-bit code for a chest hole, like first 6 digits from the right would correspond to a slice from 1 to 63. Then 7th bit, if we use floppy decoder, is for left or right side. And we take 8th and 9th bit to determine which water stream to use, or basically to determine destination of where the items go. And 10th is used for selecting either left or right chest hull, for me at least. That's how usually people do it, I believe. So for chest hole, I use 10-bit encoder by Basil. I will not be explaining bit grouping like very hard because I'm not expert at it, but what we need to know is that we have 2 rows in 10-bit encoder, so we can have 8-bit with like 2 levels as well, but with 10-bit encoder, like our example, we have 2 levels. Bottom level is basically corresponding to first 5 bits, top 1 to second part of the code, like second 5 bits, or if we read from right to left, it's first, whatever. So if you want to get a code, per group, we can have only one occurrence of an item. So for example, if you wanted to give a code to redstone dust, let's say like full ones, we would have it in the first chest on the right, it would be 5 ones, and first chest on the right on the top. So in total we have 5 plus 5 bits, and that's how we get a code with bit grouping. It's just an optimization to use as little chests as possible, basically. So priority manager is really important device. It's quite easy to understand, I believe. What it is basically is nearest, you can say. Like it has a few inputs, and it will output a signal to only one slice that is asking for permission. So even if you would at the same time ask for like all, like on the screen for four different tasks, ask for permission, it will stop at the first available one. It will give permission to that one. So this way we can queue tasks and make sure that only one at a time is processed. It's important because like we share encoder, right? So if we want, for example, with remote bulk, if you want to input items and retrieve items from it, we cannot at the same time send code to the bulk from input and request the same code at the same time unless we wire some extra logic for that. So we have to make sure that, for example, we first process input, we send the code, send boxes and the task, and after that we will take boxes out, right? So if we wouldn't do that, our remote would just go crazy. It wouldn't know what's going on. Okay, so decoder is basically a device that will output a code in correct slice or a signal in correct slice that we want based on bits we selected. And we take readouts. We don't have to. They are nice. For example, for overflow protection, we can, like, it can, with overflow specifically, we can decrease processing time of our chest hole if it gets full. So comparing to filter-based storage, if your slice would overflow, you would unload the whole box of that item anyway. It would go over the filter, and then to overflow, you would have to load it again. If we have readouts, we can check if the slice is full already. So when we send a box to unloader will just not unload it, maybe depending on your logic, directly redirect. It will redirect that box to the overflow right away, or send it to somewhere else. It will just decrease processing time. If in encoded storage we wouldn't have readouts, that's also fine. It will be a bit slower for overflow because you would just have to check at the end of the water stream if items are coming, because if they are, it means they aren't landing in the slice, so you are overflowing, and then you can send signal to your unloader and tell it that, hey, our slice is overflowing, stop processing, and it will reset after that. So they are nice. We can also do extra logic like paralogic. So we would have we would fill chest up to certain signal strength with loose items, and above that we would put boxes in. There are better explanations on YouTube for that, but that's basically it. That's what paralogic is about. I tried to do double threshold paralogic, which means I would put boxes into the slice between two certain signal strengths. So we would not very often end up with a situation where we would only input boxes, which can happen with paralogic, but yeah. So let's talk about the buffer for a bit, because this was basically the part that for me was the hardest, because there wasn't any public example of how to do it, other than maybe the matrix hull from Andrews, I believe. Or was it J-Roy? No, I think it was Andrews one. Yeah, so to parallelize our encoded chest holes, we need buffers, right? Push changing slides, hello. We need buffers. So if you wouldn't have a buffer, and we encode boxes one by one, and we send a code to a chest hull, like we would overwrite our last code, we would randomly select slices, or we would be able to only achieve 1x hopper speed, because we would otherwise you would have to check if that code is being unloaded or not. Like this, we can ensure that each buffer corresponds to one unloader, so one side of the chest hole. And we can just queue boxes in buffers and achieve parallelization. Yes, you can, but that's how I've done it. I will try to talk about how else you can do it, because I realized a lot of things after building my storage could be done better, more efficient. So we can actually hop to my storage and see how it's done. Well, over here. So, okay, it works. So I have my buffers over here. I attached request manager directly to them because I was kind of lazy and it works. So that's fine. So the way the logic works for the buffers, right? From the splitter boxes go through whitelister and everything. If we determine that those are not bull boxes, they go into temporary buffer for the encoder, and we encode every box one by one. And we also, and if it's a match with the encoder, so it means, yes, this item is being sorted into one of the slices in chest holes, we also generate a code box and send it to buffer, right? So we encode boxes one by one, we give them a code box. Then we want to send both to buffer. So what is inefficient about my approach, what I've done, is I will talk about that later, right? What I was talking about, yeah. So we send boxes to buffers. We have to send boxes to buffers, and what's inefficient about my approach is I have like a central buffer device. And the problem about that is if we are already unloading and we want to switch to a different item type, serialization doesn't take that much time. That part is fine. But our item box has to travel from here to the unloader, and that's a major bottleneck actually. If I remember correctly, it takes like 8 seconds to travel. So we could reduce a lot of time, a lot of processing time switching between item types if you would implement the buffer right next to the unloader. That's basically how you should do it, I believe. So that's inefficient about my approach. I was oblivious to that when I was building it. So yeah. So one important aspect about inputting boxes into the buffer, you have to make sure that both item and code box are input exactly at the same time. Otherwise, you could end up in a situation where you would ask for permission. It gets permission. You unlock your hoppers for like half a second, and you have first slot in the chest free, right? So you could have a situation where you get, for example, item box into the buffer slice, but your code box is not there yet. So let me get some. Actually, no, doesn't matter. So then, if you would start processing another item, what the system would do, because Hopper will pull first slot out of the chest, right? You would take the new item box, but since the code box for that item has not arrived yet, you would take code box for a different item. So it would not break the system, but you would miss sort items, right? So that's why it's important to input both at the same times. So you are asking why I use two encoders, right? It's just easier to wire, that's it. You could use single encoder and that's fine. For me, having chest hull and bulk as like fully separate systems, it's easier to wire. Yeah, it's skill issue, sure. That's what it is. I mean, it has some advantages, meaning your bulk is completely independent from chest hull, so they don't share encoder. For this system, it wouldn't actually decrease your speed of processing for chest hull because you end up with a lot of backlog of boxes in a buffer anyway, so that would be fine. But if you would want to, for example, use matrix files, I believe that would be a big bottleneck to use single encoder, but I'm yet to wire working matrix with, so we will see when I do that. So if you guys have any questions regarding buffers or anything I talked up to this point, feel free to ask either in Discord or in chat. If not, we can go to the next slide. Actually, yeah, I can talk about buffers some more. So technically, you don't need to use code boxes. They are just convenient because you are sending a code for later. It's faster to read code box than to run items through encoder again. Yes, it's more compact. That's actually no. I don't think it's more compact, but maybe
It's
it
more
is.
compact because the other option would be to store them as like observers pushed up and down if you don't want to re-encode it.
Oh, you mean just code boxes versus shift registers? Yes. What I meant is using like saving code versus not saving code. So you don't need buffers with code boxes. You could use, for example, whitelisters. So first you would whitelist boxes to correct buffer. Then you would one by one encode boxes to encoder. You would serialize code to the correct hole and send codes that way. That's slower. Encoder is slower than just reading a code box. Or you could first encode a box, send it to buffer based on code, and then re-encode without using code boxes. That's an option as well. It's slower, but that also works. So code boxes are probably just the most convenient, the fastest way of handling that. Okay, let's go back to waypoint, I guess. Where is school? All right. As for the unloader, I used Basil unloader. This is one of the things that I wired really poorly. You should not copy anything I've done regarding unloader, but what you want to from your encoded unloader, you want it to handle both full boxes and partials. So you want the ability to put full boxes into the slice without unloading it directly. It will unload non-full boxes and it can accept readout. So as I talked before, based on readout, we determine if slice is full or not, half filled if you are using paralogic. You basically want your unloader to be able to recognize that and speed up processing or do extra things that way. What is actually a code box for people that may not know? In a box, we are sending a code. We are doing. This is just most common thing to use, bottles and any other unstackable of your choice, because you can very easily sort water bottles using brewing stand. So bottle would represent 1 and shear, in my example, shears would represent 0, and that's how we store our code. Why packets compared to other solutions such as shift registers? It's just much more dense. We can save a lot more codes. And like in a single double chest, you have 54 slots, so we can save 54 codes, and it's very compact. Yeah, and you don't need to re-encode, as I also said before. It's really fast to read. It requires some extra logic, though. We need a device that will make us our box of code. Yeah, we store it in bottle shears. And one important thing, you need a device that will basically recycle our contents of a code box. Without it, you would need to constantly use like either crafted with iron blocks for shears, glass for water bottles, and you would be running low on it very soon. So what it is basically, you need an unloader for code box packets. Then you need to sort them using brewer stands into correct loader. And full boxes you send into a buffer, and you have unloader before your codebox maker, and that's basically what it is. It's not difficult to do, but my approach was not the best because I was sending full box to the unloader instead of uploading at the same time as reading the code, because I'm not doing anything more with the code box. So I should just instantly unload it instead of repackaging it and then unloading later. But yeah, just if you want to use code boxes, just keep that in mind, I guess. Okay, before we move to remote bulk, do you guys have any questions regarding chest hull? If so, please ask them. I feel like I'm moving very fast, not going into much details, but yeah. Why not multiple codes in one shulker? Yeah, so you would have one item box and one code, right? So you have the exact same amount of storage for item boxes and for code boxes. It's just really elegant, really easy, since one item box equals one code box. If you wanted, you could have one code box with 9 bits and have 3 different codes in there. But yeah, I don't see how that would help you actually in any way, shape or form with chest hull processing or even bulk. I have not even considered using that, but technically that's an option. But yeah, like with one code box, one item box, it's really easy to manage. Okay, so regarding remote bulk, my opinion, the most cool part of the whole storage, being able to call boxes, it's something I really enjoy. Giannis, hello. Yeah. Okay. So if you want to input items into our remote bulk, we need a buffer. So I use toggle buffer plus grouper made by Basil, Skyzy, and Kizu. Grouper by Monica. So we need a buffer because we will be sending a lot of boxes, maybe of different types. We want to store them somewhere, not just as an item entity, but in containers, right? And we don't want to be sending boxes one by one to remote bulk, because that would be just really fucking slow. You know, encoder takes some time to run. 8-bit is, I believe, like 140 game ticks, so it's like 7 seconds, and then there is travel time of items in water streams and everything, faders at the remote. So we just want to send a whole group to the bulk, as many boxes as possible at once of the same item type. That's why we use buffer with grouper. We group boxes. So after the grouper is done, we have our group. We are sending a single box to encoder in order to get our code to the remote. Other boxes can wait anywhere. I have simple, just like a few double chests of buffer, so they are not waiting as an item entity. In case that's useful in case encoder would malfunction for some reason, your boxes would not despawn, right? So that's nice to have. Always use containers as buffer and not just water stream somewhere as an item entity, right? So our single box will go through the encoder. It will be rejoined with the group. Our code will get serialized to the remote. Remote will select correct slice, and then we'll start sending boxes. They go. As they go, the fader is activated. It's timed that basically almost instantly as the last box ends up in the slice. Remote bulks resets, it locks the slice and sends ready signal to our request manager that it can process another task, right? So inputting is really easy. If you have any questions, please ask. If not, we can go to the rest talk because it's a bit more advanced, I believe. Okay. Okay, what do I have next? Okay. So for our restock hull, like our quad bulk, the main UI we are going to be interacting with when gathering resources for some projects, right? The logic for it is not that complicated. Wiring can get a bit advanced. It's not bad. It's really easy to understand. But so I don't have any slice on hand. There are some posted, but basically first the way restock hull works, you would make a list of every slice that needs restocking. It's just a bunch of I'm losing the word. Not levers, Jesus. Okay, I forgot the word. Oh yeah, a bunch of latches. Yes, that's what I was looking for. Thank you, Ragdoll. Really. Yeah, so it's just a bunch of latches. We trigger them if the slice is empty. If not, they are not able to get pushed. And then if we have permission from our request manager, meaning that bulk is idle, nothing is being processed at a time, we can move our pointer item. You don't have to use pointer item in the wiring, but that's the most common. So we move pointer item to the slice. It's just a dropper chain. It will stop at the nearest empty slice because it will just not get triggered. It will stop there. And then it triggers a code. The code is sent to the external bulk, and also on the way it's wired in my storage, I copied it from Redwave MS. It activates another latch for the remote. So to make it more efficient, right? The latch basically determines when you unlock a slice in your remote, whether is it a input request or restock hull request. So if it's restock hull request, the unlocking on the slice itself will trigger a counter for the item call, and will call 54 items in case of my storage. And after that's done, they go through the water stream, they activate a fader over there. It's like 20 seconds, I believe. Once they are in a slice, it sends a ready signal to the encoder, and we iterate through the slices one by one this way. And that's the whole logic of it. Yeah. Any questions? I'm not sure if that was clear what I said, but Okay, maybe we can go to the storage for a moment. Yeah, so for my haul, only I used hybrid haul, meaning the bottom two chests are for bulk and every other chest is for chest haul items, right? So it's basically half of a usual quad restock haul. I like hybrid hauls, so that's why I use it. Let's go to the list makers to explain maybe a bit more, right? So normally you would have a first dropper before any slice, and it holds a pointer item, as I said before. When you activate it, it will, yeah, on the right we have latches. If the piston would push this concrete block, for example, this observer would not be able to power this dropper, and that's how the pointer stops at the correct slice. We take a readout from that. Essentially, comparator reads the content of the dropper. If it finds that it's powered, it depowers the storage, and that way it resets latch, and at the same time it will trigger this rain line, which will set our code in the serializer, and after some short delay we will serialize the code, right? And it will be sent to the remote. And where was the line for the latch for restock? I don't even remember my wiring, but it was somewhere here. Well, either way, I don't remember. I'm sorry. And yeah, that's how it works. Okay. What did just explode? Uh, I don't know. It doesn't matter. Maybe it broke something. I have no idea. That's funny. Oh my god. What was I on about? By the way, we can go back unless you are watching my screen. Then we can go back to the class place. Is it the last slide? I think it is. Yeah, you can fix it. No worries. Yeah, I have some more things to talk about after that, but for the basics, we can end on the item call box. How we are even calling items from the remote using the call box, right? I mean, I can always go to the single player world and demonstrate on that if something doesn't work after the TNT explosion. I'm sharing a screen anyway. Sure. So for item call, I basically copied what Red Wave did again. what Basil did with item call. So, yeah, I will actually go back to my storage. I think it will be easier to show an example than using the slide in the presentation. So we have really nice, comfy UI over here with I have 4 double chests of items that you would most likely want to call from your storage, right? In case they were not in the restock hall, and you don't want to trigger the whole restock sequence, or you want more than a double chest of boxes of some item for crafting purposes or whatever else you need, right? So we have nice UI next to the crafter. If you want to call, for example, X amount of boxes of an item, I set my counter to 9. So single item of redstone dust would correspond to 9 boxes of an item. I don't think I have any redstone dust in the remote, so we can input some really quick. Let's hope it works. I'm not sure if tick sprint will work, but let's see. Okay, we can look at the status lamps. So it's running. Okay. Input paused for... Oh, it doesn't have empty box storage. Okay. Yeah, that doesn't matter. The bulk is not connected to that. So now, if you wanted to call 9 redstone dust, right? I took one out of the double chest. I put it into item call box. So I want 9 boxes of redstone dust. We will send our item call box to the encoder first. I mean, first to the temporary buffer. It will ask our request manager for permission. Oh, okay. Tick right. Oh, all right. Player call is quick, so yeah. So once it gets permission, it will get dispensed from this dropper. It will go through encoder, get a code. And I have 2 latches over here to determine where the box will end up after the encoder. So since it's item call box, it will go to the splitter. It's by Halesmaker. Yeah, over here. I hope it worked. It should. So it will dispense items one by one, and it will send a signal to the remote. For each one item, one signal, there is like a secondary counter connected to main counter to multiply our 9 box calls, right? So that's why we can call for example, we can put 3 redstone dust, and it will instantly call 27 boxes instead of doing 9, then going through encoding process again, doing 9 again. That's just a nice optimization. Yeah, so we got our 9 boxes of redstone dust. And for the items that are split from the item call box at the encoder, there is 4 latches that would unlock the correct chest at item call UI. And that way, when we split items from the item call box, it will land in the correct chest. And after some time, it will get locked and the box will end up in the box place, basically. That's how it works. If not for the Redwave MS, I would never have found this box splitting device for item call. I'm not sure what I would do, honestly. Like, I found a lot of cool stack because of it. Yeah. So we can call remainder of the boxes that we input, and and they will end up in here. So yeah, for example, Cycraft MS doesn't have this feature. It will iterate through item calls one by one, and they have different container for successful calls and unsuccessful calls. This is just faster, right? If you call a lot of items at once, this will be a lot faster. And we all obviously want to access our items as fast as possible, right? So you may... What the fuck happened to those chests? Hello? Oh, never mind. Non-synced items, whatever. Yeah, so you might wonder what would happen if we input empty box, for example. There is protection for that. The process would not start. Our box would just come back to here. Yeah, boxes are coming, right? If we call for an item, it's not in the remote. It would process everything just the same. It will you would just not get your items, and the process would work as intended. Nothing else changes. So, okay, we lost some boxes somewhere. I have no idea where. It definitely worked on single player. I don't know. Well, either way, that's how item call works. As I said, in my opinion, this is the coolest part of the whole encoded storage, and the second coolest thing is being able to automatically input both boxes and items into a slice. That's one feature that I love with encoded chest hulls. Unfortunately, 2x parallelization is not really enough to compete with filter-based storages on speed. With two hulls, in theory, we can achieve up to 4x unloading at the same time. But for example, with Hermitcraft Season 9 item set, I believe that's what I used to test my storage. At most, we are getting like 1.5 stacks of an item in a box, usually. So we are unloading very little amount of items, which means we are wasting a lot of time switching between item types, as I said before. Mentioning the buffer before, right? That's a major bottleneck of the system for the parallelized speed, or even non-parallelized. Like, we are wasting a lot of time switching between boxes, because first we have 20-second fader to lock the slice, so the item can go to the slice, go to the chest, not stay in the hopper, and to lock the slice. We need about 20 seconds for that. And then the item box has travel time from buffer to my chest hull. So for the future, and I think that's what Suntech MS is doing, they have buffers at the unloaders. And actually, my logic would be for inputting into buffers would essentially be the same, right? Because instead of buffers over here, I would just have 4 different water streams. And that's essentially it. And I would handle inputting at the same time at buffers. So it could be rewired quite easily. But yeah, I was oblivious to that. So that's one thing that's really the piglin trap. Yeah, which is really bad about my storage. So you may also wonder what happens to overflow in a system like that. In filter-based storage and overflow, you would have to load into boxes, and that's fine. Obviously, that's how it works, right? But with not even with encoded, but with splitter-based storages, we have single item boxes. We don't have to unload them if we are not certain that they belong somewhere, right? So what happens essentially, the box goes through various whitelisted inventories, right? So first, from the splitter, we have bulk whitelister. Where is it? Oh my god, this storage is all over the place. Yeah, over here. We have 18 game tick box whitelister for bulk items. So our bulk items would go straight to the. If they are full, they would go straight to color coder if it's active, and then to bulk. If they are not full, they will go to. If they are not full and not empty, they go to the temp, then to the merger, and it's a loop, right? I'm not going to be explaining variable sorting loop over here too much. It's about encoded storage, right? So yeah, first we check for bulk. If item is a bulk, we separate it. Then, in case of my storage, everything goes to the main chest hull encoder. So if there is no match over here, I also wired some simple MIS. So from here, if there is no match, it will not go to overflow or unsorted directly. It will go to our MIS. I copied slice from fully hopper locked miss, if that's what the name was. FH miss, MIS. Yeah, so we run each box one by one through whitelisters, and then we unload or put boxes directly into the slice if they are full. So after that, we basically checked if it's a bulk item, if it is chest hole item, or if it is MIS item. If it's none of that, then the box can go to wherever you prefer. If you have any other processing, you can go directed to that. Or in this case, it will just go to the unsorted over here. Yeah, so we have a lot of player herds, renamed items, or a few items I forgot to include into my item layout, which was very hastily put together. I hated doing that, so I spent as little time as possible on that, which is why it's all over the place. Hello? Who's doing explosions again? Oh my god, doesn't matter. Yeah, so that's why, for example, I'm storing every fucking copper item into its own chest. I made item layout before I even decided that I want MIS. So MIS has like enchanted golden apple and armor trims, and that's basically it. My storage has exploded. Holy shit. Yeah, so any bulk overflow, I have not fixed it on this server. I found it like a week ago. I forgot to power this one dropper, so any overflow would stop in this dropper, but I should have powered it from the bottom right. And it will just go redirected back to the system, to the overflow chests I included over here next to the crafter. And for chest hole, if it's overflowing, I have overflow across it. So everything has its own place, right? I also have this cute code display. It should be somewhere else because it would be better to have peripherals over here, but yeah, it's not the best put together storage ever. But it works. It's nice. It's something to look at if you have no idea where to start with Encoded, I guess. I also have Encoded unstackable sorter. I'm using UI by Hidden Squid, but I don't think I'm qualified to talk about how that works, so it's not even important for this. I believe just the item. Okay, half about it is like item layout. The other half is like having only 2 holes instead of 3. So if I have 2 holes, there is more space to put peripherals like this in a cross pattern, right? If I would have hole over here, my item call UI would be like much further from the holes themselves, and I wanted to have everything accessible, and that's my reasoning. For the future storage, I'm not sure if I'm gonna go hybrid again. As I stated before, I believe 2x parallelization in Encoded is just too slow to make it that worth. Like with very little item quantities, your system will be painfully slow. If you have a lot of items of like a lot of a single item in a box always, then it doesn't really suffer from the from the from the time to switch items. I don't know correct English word for that. Yeah. So my current belief is that we should be using matrix hulls for encoded, but I'm yet to finish my unloader. It's not easy to make everything compact. Hull itself is quite easy, but the unloader is it's hard. So if I manage to do that, V2 will be probably matrix hulls and quad bulk instead of hybrid layout. I'm actually curious to see with Soon MS how fast that will be, because as I said, I'm wasting a lot of time with my buffer placement, right? The processing can be much faster. So maybe it wouldn't be as bad. And also, everybody's item distribution in single player will be different. Hermitcraft item set is kind of unique because there is a lot of items of very little quantity in the boxes of player heads and shit. So the system like this is very slow for that. But maybe for typical survival application, it would be better. I have not used encoded storage in survival players, so I cannot really tell, but I can imagine it being quite okay, actually. Are you sure about that? I mean, it's fine. I don't need to interact with it right now. About restock, one more thing about restock hull. So I wired it in a way that it's just a single task. So it will restock every quadrant in order. So if we have a lot of empty slices, which you would not deactivate by levers underneath, the restock takes like, I think 2 hours it is with every slice empty. So if you would build it and start assigning items, it would be best to activate every lever and only deactivate them once you know that item that you have such item in your remote. Otherwise, you will be spending a lot of time waiting for the restock, right? So what you could do is have every quadrant work independently. So you would trigger restock for a single quadrant at a time. That would be a lot of extra wires, a lot of slices of our request manager, but that's one way of doing that. You could also have insane amount of wires to the remote and have 4x remote bulk if you wanted. That's an option. Or use water streams, I guess. So yeah, that's something to keep in mind with restock halls. The restock is not very fast. Mainly because the remote doesn't really know if it, like, I don't have readouts at the remote, right? So even if the slice is empty, it will trigger the 54 item clock, and it will wait for that to finish. And then there is a fader, 20-second fader from that. So yeah, that's why it's slow basically. You could have extra logic to account for that, but yeah, doing readouts at remote bulk can get complicated really quick. But if you wanted to do encoded crafter for your storage, that would be nice for sure to have readouts at the remote, right? Mm-mm-mm. I'm not sure if there is anything more I wanted to talk about regarding this storage. Mm-mm-mm. I guess it's time for like all the questions that you may have, or if you want me to explain anything else in more detail, sure, ask. Because I already explained the basics, I think, so. Overall, when I started putting this storage together, I already knew how to do remote bulk. I knew how the logic works. I just had to figure out the chest hull part, right, with the buffers and everything, because as I said, there is no other public example of that. So you would always ask and get a response. Oh, just do X, Y, Z. It's easy. Just do that, this, and that, and yeah, that's the answer you get every time without any examples. So I had to come up with something. That's why I did the centralized buffer, as I call it. So yeah, I started by wiring chest hull logic. I wired front ends, everything. I connected my encoder, a codebox maker, buffers, and I tested only that. I had a pre-prepared like set of split boxes already. I ran some item set through the splitter, and I was testing on that. And that's also one thing why you would want to include safety features, if not for the ease of fixing storage later. Even when you are building something, right? If you have safety features, it will stop cascade effect. You obviously can always repaste stuff, but for example, when I made my item layout with command Leo scripts, I forgot to delete the duplicates from my Excel spreadsheet. So some encoder chests in a group had the same items. So my encoder was getting scrambled, kind of, but it wasn't like it would still encode the next box because, for example, I had four birch slabs over here, right? So it would take one birch slab out, and there would still be three. So signal strength 2, safety feature. Okay, there is signal strength 2 in every slice. We can process next box, right? But because the way I did input to the buffers, both hoppers will wait for an item to be in them, and only after that they will be input. So I was not getting item box back, only code box, and my system was stopping there, and that saved me a lot of headache regarding all the logic and everything when building storage. So safety features are nice. Whenever you can, you should include them, especially with Encoded. In my opinion, Encoded is actually quite easy to fix when it breaks because of safety features in a lot of devices, right? The encoders will check for item return, hopper cards return, and possibly more, whatever you implement into them. So if anything goes wrong at the encoder, nothing else gets processed. There is, I don't think I have toggle states anywhere, which is just a good design practice, right? To not have toggle states. Unless you treat latches as toggle states, they are not really. Restock station has toggle? Maybe. Maybe it does. Maybe it doesn't. Yeah, I guess it does. But I think it will self-reset. I'm not sure. Yeah, but whatever. I guess there is a toggle over there, yeah. So yeah, latches are very easy to reset, and because usually you would use, at least I try to use piston latches instead of dropper latches, because it's easier to see state of the latch, right? You have a instantly physical representation of the state of the latch. So if you know that nothing is being processed and you know that this composter would be up, there is something wrong over here. You would investigate over there, and latches are very easy to reset. Just push a piston with a button. No happy gust. Why would you need happy gust? Okay, what specifically about readout logic? Restock. Oh, restock logic. Okay. Do we have any like quadbook slices somewhere to look at, or maybe I can paste somewhere? These
I have a
shaders are kind
quad
of broken.
if you want to look at it.
I mean, sure. I mean, we can use my hole, but I think maybe slice would be easier to explain on.
Okay. I'm at it if you want to TP to me.
Over here? Wait, where are we?
Here, I'll TP you. There we go.
Oh, I'm sorry, I was not looking at Discord. Do you have signs for everything or not?
I
Not really.
don't.
Okay.
But
Okay.
yeah.
We can. I mean, we can work with that, I guess. So the way you would do it usually, to start the restock, the way I wired it like this because I was copying what Redwave did again. So when I ask for restock, it will first make a list of every slice. Okay, what is that? Which was the list making? Yeah, this was the list making, right? Yeah. So you would give a signal to this rail, and if the chest is empty, this is not pushed. This piston will be able to be activated. It will QC power this one, and it will trigger this latch, right? This dropper is our. It reads slices, or how to maybe call it better. Okay, with this dropper chain, we would iterate through the slices, right? So if you have a few droppers in chain, over here, we would we trigger rails rails from the top, because the way rails update is from the furthest to the nearest. So if we trigger this part of the rail line, it will trigger from here, right? So this observer triggers first. So if the latch would activate and it would be in this state. You have this solid block would be over here, and we trigger this dropper with a dummy item. Let's do that. As you can see, it stops here, right? It stops in this dropper because it was empty, latch was pushed. Our pointer item stops here. So let's destroy this because we have a slice. So let's say we have our pointer item over here. Let's first trigger the latch. Something is missing. Either way. Oh, yeah, let's do it over here.
Yeah, the left side is missing.
Yeah. Okay. as you could see, we triggered this rain line, right? So pointer item ends up here. If Jesus. Okay, we made a list. Latches on the bottom. Pointer item stops in this dropper. Latch gets reset. We have our code over here represented by observers. And we send code to the serializer with each rail line representing a single bit, right? That's how we even get the code to the serializer. So we have our latches for the serializer set. We can send the code. After that, as I explained before, correct slice unlocks. Our counter for the 54 counter is activated. We receive items. Once it's done, it resets. It sends ready signal to the request manager. And if the restock was not finished, meaning our pointer item did not return to the first dropper, like here, for example, it means our process is still ongoing. We will get permission to iterate through slices again. So if you would have second slice, right, this latch was already reset. We sent a signal with this rain line. Cute. So it will just end up in the next slice, right? And again, it will reset the latch, send a code would get serialized, and that's how we iterate through slices. That's how we send a code, and that's how we are able to determine which slide needs restocking. The pointer item, okay. Okay, you have the full wired quad over here, right?
Yeah.
Where do you have the first dropper?
It's right here.
Oh. Jesus. Oh, yeah. So there is dropper for every slice, right? But we have one extra dropper on the front end. So that's where pointer item sits by default, right? In idle state. And actually, that's how we also know that the quadrant is done, because if we send, let's say, no slices need restocking, we send pointer item, right? It will just go through every dropper, get dispensed over here. It will go back to our to our front end. It will end up here. So if we take it out, right, as you can see, those droppers are deactivated. Once it's back, this is how is it called? Jesus, I'm blanking. Jesus, let me see in the Discord. How was it called? Like the logic gates, like when you get the.
I can explain a little bit
No,
if you want.
no, just how was it called? Because I forgot.
Rising edge?
Yeah, it's rising edge, right? So it will activate when it's back. It activates the rising edge, and it will send a signal to whatever. If it's the last quadrant, it will send done signal that the restock is finished. We can end our whole process for the restock, and priority manager gets reset for that, and that's the end. If not, if it's not the final quadrant, it will just usually send a signal to the next quadrant, and it will power dropper line for that. And we would iterate through slices in the next quadrant, right?
Yeah.
Yeah, so that's essentially how Restack Hull works. I believe it's actually the easiest part to do if we consider encoded storages. Well, we already had a few hybrid storages, right? Meaning, like for most people, it's quite easy to wire. If they know how to do encoded storage tech, then restock hull is quite easy. You mean in the single quadrant multiple pointer items, or? Yeah, because in the one quadrant you want one pointer item. I don't know how it would work otherwise. If you want to parallelize your quad bulk, you can have each quadrant work independently, and then you would have one in each, independent of each other, right? But yeah, like this, with those quads that are not parallelized, you can only send one side at a time, right? Because if I would send this pointer item, it would stop at, for example, second slice. And over here, at the same time, I'm sending this pointer item to first slice. So you would get, at the same time, code for the slice number 1 and number 2. So, in essence, you would actually send code for slice number 3, right? Because it's first and second bit. You would just unlock the wrong slice in the remote. So you have to do it one by one. Okay, let me take a look at my remote. If there is anything here that I would want to talk about. Essentially... Hello. Again, I copied most of the wiring from Redwave. I just used their newest multi-sliced slice. So yeah, my remote supports multi-slicing. If I remember correctly, I have 80 slices. So 16 of them are assigned currently to 0 code, which I'm not using for any item. It's not... Oh, 106. Oh,
wow.
Jesus.
Okay.
I mean, it depends what you want to store, right? For example, if you would want to actually integrate a good encoded crafter, right? You would want a lot of slices, for example, for cobblestone or for wood, right? Because those items are probably the most used. Like you would want a few, even tens of millions of cobblestone in your storage, right? Because both cobble and stone, I guess, because stone is used directly in the recipes as well as cobblestone. So that's main reason I did multi-sliced bulk. First, it doesn't really cost you anything to do it. It's a few extra wiring things which were actually already included in the download. So it was a no-brainer to do. And yeah, it's nice. Originally, my idea was that I would keep working on this storage, include restock for things like super smelter, right? Or I wanted to... Actually, I still want in the future to work on encoded crafter, but yeah, it will not be for this storage. I want to wire something better. So yeah, that's the reason I did multi-slicing. I also included this lime glass as a reset sequence. I have not tested if it works, so if it doesn't, life, I guess. I think it should work. Basically what it is, it will reset every latch that is in the remote. It will lock every slice, and it will clock all droppers to empty any items that may have stopped in a dropper in case of server crash or something.
How does it clean out all the droppers? Does it just like pulse it a bunch of times, or is there some detection method?
Yeah, there is this comparator fader, right? And the change in the strength of the dust is detected, and it triggers dropper lines, basically.
Okay.
That's the same as red wave. Yeah. When it comes to restock or like the whole remote bulk, it's like 50 or more percent copied from red wave. Maybe wired for my needs, but yeah. If you would follow the logic, it's exactly the same basically. I even copied the counters and stuff, so when it was already wired pretty good, I didn't see a reason to wire it myself.
Is this the same counter as a low you're using for your book?
I'm not sure which one Lou is using. This one is really simple,
Yeah, looks
right?
the same.
You just have two droppers pointing into each other on 8 game tick clock, and droppers are detected with observers. And
Yeah, this
Yeah.
was just the like Mazuma game counter, right?
yeah, probably yeah. As I said, I copied it from Red Wave, but yeah, I think it's Maizuma Games one. It's n+1 counter. So for the item call, right, there is two counters, as I said before. The first one, it's over here. So we can request up to 64 times 9, in my case, boxes. So this counter will be triggered one by one when this one finishes. The main one for item call, which is 9 items. And that's how you multiply your item call. It's really nice, really easy to do. I don't see a reason to not do it this way, because like in SciCraft you would, in SciMS you would request 27 boxes, if I remember correctly, at the time. So if you wanted, I don't know, 9 double chests of an item, it would take a long time. With this, you would have a continuous stream of boxes until everything is delivered to you, right? If you wouldn't do that, you would have to re-encode every time your item call box, which is not ideal. Yeah, accessing items from remote is already slower, I guess, than going through the chest hall. So we don't want extra inefficiencies over here, right? Yeah, I guess this is technically, you could call a toggle, but not really. It's kind of same as with copper bulbs. If you just use them for change of state instead of actually using a comparator readout from. Yeah, if I remember correctly, this dropper line is like 160 blocks per second, if I'm correct. One nice thing that is done at every redstone line is if you trigger it, it will only increase or decrease the signal. So if you would, yeah, it's single edge, yes, single edge. So if you send one item, it will just change state to 15 instead of going 15 then to 14. And I think I included it everywhere here. Yeah, it's over there as well. It's slight lag optimization. I personally don't even believe in that small optimizations that much, unless mainly because I develop for single player, but you would call, I mean, most people would consider this multiplayer storage, right? But I don't have multiplayer in mind when I design my things, so I don't think this lag optimization stuff matters this much, but it's free to do, so why not? It's just a good design practice, right?
Yeah, it's actually a really nice way to use toggles for these lines.
Yeah. Yeah, I actually found out about it from RedWaveMS again. Well, most of my wiring practices are learned from looking at Basil stuff. Their videos helped me a lot in understanding everything encoded. Unfortunately, they are not public anymore, but especially the chest hull explanation was great for me. So we can actually go back to talking about readouts. So in my hull, right, I have 40 blocks per second readouts. I don't think that speed actually matters. It can, in my case, it definitely doesn't. But it's not that hard to implement 40 blocks per second. You can teleport to me, by the way, if you want. If not, that's fine. I'm sharing a screen as well. Was it like this? No. So it's 40 blocks per second because we have comparator every 4 blocks. So in 40 blocks, we would have 10 comparators. Each comparator has 2 game tick delay, which sums up, right? So you may wonder how to actually do readouts with this, because every 4th block, we are not reading signal directly, but we are subtracting. So that's the main explanation from Basil that was really nice to me. So we have to detect for which code we are which slice we are unlocking. At the end of the hall, I have extra. Is it at the end? Oh my god, I don't remember anymore. I think it is. So, is it? Yeah. Yeah, we have. Yeah, because I have decoder on the top. So every fourth code has the same pattern of 2 bits at the start, if I remember correctly. So we detect for that, and we trigger a latch every 4th slice to change from adding to subtracting. So we need one at the end to activate our signal, and one at the front to flip the signal, right? Basil called it a flipper because it flips a signal. So if you would have like completely full chest hull, signal strength 15, right? And you would send a signal directly, we have signal strength 15. But every 4th slice, you would have to subtract that signal, right? Because we are pointing into a comparator. That's why we need a signal source at the end to be able to determine what is actually the state of our container. So basically, we first subtract, and then we subtract again to have our original signal strength. And that's how you do 40 blocks per second readouts. You don't have to do it this way. It's nice. Just as other things mentioned before, it's free to do. There is space for it in this hall, so I've done it. You may also wonder how we are getting our signal to the chunk loaders. Because I actually, at the start, I did not know how to do that, but it's quite easy with encoded storage. Like, at the start, you can detect like box going over some water stream. That's easy, right? But then if you have your boxes in containers always, you will not have any pressure plate or any string with observer to detect. So we because we are using priority manager, we always know if there is a task queued, if there is anything to be processed. If there is, we just take signal from the request manager to the chunk loader, and that way we have that, we know that the system needs to be chunk loaded, and that's basically it. Honestly, that's all there is to it. And I as I said, I forgot where my wiring is, so it was somewhere here, I believe. Yeah, actually, why do we know that? How do we take this readout? If any of the processes is started, this redstone block is pushed, and this redstone line is activated, is active, and from there we have a connection directly to the chunk loaders. That's how we activate them, and that's... I read a few containers like that in the storage to chunk load. It's easy to do. I have not finished wiring like manual chunk loading. I just have levers to like at directly, like over here, for example. For this is for pausing, I guess. There was one lever somewhere to activate the chunk loaders. Yeah, I UI for this is not connected. I did not feel like finishing that. The whole panel for status lamps was like major pain for me, so I didn't want to finish that. Yeah, so pause is not fully functional. Those are not functional at all. Copper locking is not functional as well. So I guess those 5 are, if I remember correctly. I think disabling MIS, unstackable, and it was supposed to also be color box, is, if I remember correctly, it's only like redirecting water streams. So instead of box going to MIS buffer, it would go to overflow. And that's how I pose it. So if there are items to be processed, they will get processed instead of being posed actually. Yeah, it's not fully finished, but as I said, I want to finish to wire something better. My chunk loaders are like all over the place. This is just atrocious, right? You could have it so much nicer if I actually put any amount of brain power into placing my holes in the right spot. I would be able to reduce amount of chunk loaders by a lot. So that's something for my next storage, I guess, to do, to have better chunk loading grid. But yeah. You may also wonder why I used this temp storage. It's variable temp storage by 777. And my answer is I don't like prefilling inventories, and I didn't want to use encoded temp because it would be slower than this. So variable it is. It's actually quite fast. So it was not able for me to keep up with 8x splitter, which is why I decided to just swap it out for 4x. It was enough for everything. 8x splitting was also too fast for my chest hull to process, so there was really no point in it, right? So the whole storage is 4x at most, which is kind of a bummer. If you wanted to use 4x parallelization for chest hull items, I believe you should just use cyclical variable sorter. Otherwise, you are getting a lot of split boxes of very little amount of items in them, and the processing is slower. And also one other, yes, Sigvar mentioned, one other inefficiency that I have in my storage regarding chest hull processing is the way I handle overflowing buffer. This actually wouldn't require a lot of rewiring, but the way I do it, I have a readout from those chests. From the code box chest. It doesn't matter which one. But yeah, I just use code box. So I think I set it to SS14. So if any of those chests would have signal strength 14, so 51 boxes inside, it will just pause my encoder. I will have, like, I will not generate any more code boxes. This buffer will be idle. It will wait, right? And this is actually a huge issue with the system, because depending on your item set you input, you might have a lot of items in sequence from like single part of your chest hole, right? You will have, like, I don't know, copper doors, lapis, any ores, stones and shit. It will all be from one quadrant, right? So you can have like even 60 boxes from one quadrant in sequence. So what will happen is you are getting like 60 boxes of one quadrant, and it's not being able to process them fast enough. Other buffers will be just idle because of it, because this one of them is overflowing. Others are idle until this one gets emptied, right? I mean, not empty, but until it processes like 1 or 2 extra boxes. And it's, as I mentioned, is actually easy to rewire. You would just, instead of detecting, instead of reading contents of the chest, you would just continue the dropper chain, and they will just get into the like overflow or something. And you would also not wire it like this with redstone blocks. You would not have. I would not trigger those droppers. Instead, I would only lock hoppers, or rather unlock hopper for correct buffer and just have slower dropper line. So they would always end up in a hopper if it's unlocked. If it's full or if it's locked, it will go further, right? And you would be able to process items, like continuously process items like that. I think that's what SunMS does. So yeah, they thought about it. I didn't originally. One thing to keep in mind with that approach is Hopper will always pull the first slot out of double chest. So if you are splitting boxes and you don't have this chest full, right? And if you would redirect a box from overflowing buffer right to this chest, it will be the first box to be processed again. So maybe it's better to have some toggle buffer or something. I don't know. I have not thought about it extensively, but that's something to keep in mind, definitely. Because if your buffer is overflowing, you don't want to process boxes from buffer for
Why are
it.
you using 2 encoders?
Okay, as I mentioned above, it's, as people pointed out in chat, skill issue, right? Well, it's first of all, it's easier to wire the logic for it, because you have chest hole and bulk as 2 independently working systems. Well, they are well, it's a choice, I guess. They are only working together on variable sorting part, like splitter and whitelister, right? After that, they are separate. So because of it, I am able to use separate priority managers. They are completely independent of each other. I can input items into bulk at the same time as processing new boxes for chest hull. I can request items with our item call box without stopping our chest hull processing. That's the benefit of it. In this system, I guess you could use single encoder. You wouldn't lose much speed because you wouldn't interact with bulk. Like, you wouldn't have that many bulk items to interact with to significantly slow your chest hull processing, I guess, but you would have a lot of extra spaghetti over here to wire everything. So for me, it was easier to use 2 encoders.
Yeah, I don't think 2 encoders is a skill issue.
Yeah, not really. Well, I think it's more complicated to wire single encoder, but you already have the logic for both, so you can combine them, right? Yeah, in my opinion, it's just more elegant to use 2 encoders, actually. Yeah. Yeah, speed is definitely a concern. As I said, with this system, probably not. Because like from those test sets, split boxes, I was not getting that many bulk items. At least not that many full boxes from the variable sorting loop that it would matter at all. I guess it could
Also-
matter if you would constantly input full boxes, but
Are you doing any MIS in the chest hall?
yes, that's how. Yeah, actually, if you wanted to copy this to use to alter this item layout, because I have only 6 items per slice for chest hole, right? I'm not using all the codes, so a few of them were like copied. Like a few chests are duplicates at this moment. I don't remember which ones, honestly, but I had
Why do
no
you
space
need
for
an
like.
MIS then?
Okay, so I originally wanted to not have MIS because I wanted to have everything in the chest hole.
Yeah, why not have everything in the chest hall then?
I think it's nicer to have separate MIS. I just think it's nicer. It's a preference thing. Because with encoded system, definitely you can have everything over here. But having some things in separate MIS would also kind of give you a speed increase in your system, because typically you would have a lot of items in MIS, and usually MIS items are probably like the most common in your input sets, right? So redirecting them directly to your MIS would be nice instead of unloading them into the chest hole. So it would give you some speed increase. It's separate UI, so it depends if you like it or not. As I said, I have only like 2 items in my MIS because originally I didn't want to have separate one. I have like enchanted golden apple and armor trims. But if you want to have MIS in your hole, that's you at encoder. You will, with how many items we have, you will either have to add extra chests, so your encoder would be longer and slower, or as I did, remove some codes from the encoder and copy the same ones, so you can accommodate more items. If I remember correctly, I have duplicate chests for like banners maybe and carpets, I think. And signs, yeah, signs, because they are signal strength 16. So I had too many of them, and I was not able to go under signal strength 2, so I needed extra chests.
Wow, tripwire hook in bulk.
Is it? Yeah, but item layout is not the most thought about thing in this whole storage.
It's okay.
Honestly, some items from this, they just don't belong to bulk. One nice thing about encoded chest hull is that the question whether something is bulk or not is not, am I going to have more than double chest of an item and then it's bulk or not. With encoded chest hull, you can have a double chest of full boxes of an item before you put anything in bulk, right? So
Right, yeah.
I would not put. You don't have to have like gas tiers in bulk. Like that's ridiculous, right? What are you going to use them for? I don't know. You can't really produce that many breeze rods to even saturate a double chest of boxes, right? A lot of it is like just hastily put together I spent like half a day on this item layout. I could not be bothered to work on it. I just wanted to wire a storage, but for a storage you need item layout. There were basically non-modern item layouts for hybrid chest holes, so
Yeah. What version is your storage for? Like, what version do you play on single player?
I made it for 1.21.4.
Base.
So now I play on the latest version, 0.11, but it was
Oh.
4.4.
How long, can I ask you how long it took you to pre-fill the 10-bit encoder? You don't have to say if it's
Basically-
too painful.
Okay, I don't have built it on Survivor, if that's what you're asking for.
No, in creative, in creative.
In creative, it's like half a minute. Half a minute because I have Excel.
half a minute.
Bro, I have Excel sheet, right?
Bro.
So I have Excel sheet for you have Excel sheet for your items, and
I use a single encoder, and I did it manually. It took me about 5 hours for bulk and chest hole in a 10-bit encoder.
okay, hold on. Maybe I can share my. I can show you how I did it with the. With the. With the Excel sheet. But I don't want to dox myself, so.
Hard work versus smart work. Damn.
Okay, let me change the sharing. Change stream. Okay, so this is for my bulk, right? I changed the bit order a bit, so that's why I have a lot of columns, right? But basically I have, like, you have slices from 1 to 63. It's 4 of them. Then you have hole either left, A or B hole, left or right. And then you have code. I have like simple formulas for it. Essentially, you just take, like with a command Leo script, right? You create item list for your slice or whatever. You paste it here. You delete duplicates because it will make duplicates for some reason. And from this, you can, for example, here I have chests, right? So I can select. I'm sorry, it's in Polish. I'm from Poland, but Jesus, it's not like
Makes
this.
sense.
It's exactly for right, and I have all items for a corresponding chest. So I would copy that, paste into the txt file, save it as 4, and then I would import that with command Leo scripts as a container, and I would do it for every chest. I did not manually do that. I have some programming basics, but I don't know Python, so I asked our great AI, which I hate, but I used it to. So it made me a simple Python script. I would export my. Let me stop sharing that. So it would. I would export my Excel sheet into CSV file, and I would just. So I would just import it as like into. It would generate me the text files for every chest, right? So I would have 1, 2, 3, 4, 5, 6, 7, etc. every chest, and then I would use a script to generate encoder chests. Where is my Minecraft share screen? Right, so it was STX encoder chest. I want signal strength 1. It's GIF, and then your item list saved, right? So you can save item lists after space, right? So you can generate as many as you want. It has to be in your folder, but you can do it automatically, right? You don't have to fill them. You don't have to do anything manually. Please don't do that again. Save yourself some time.
I'll try.
yeah. Just Excel. Excel is great. Excel is great. Yeah, so you have to set up your Excel sheet a bit with like bit groups and everything. You have to know where you have like your Dmax part of the code and everything to set the chests correctly. But it's easy to
Yeah.
do.
And you said you did have MIS with your chest haul.
Yes, yes, in a sense that a lot of those chests work as MIS, right?
Yeah.
Over here, I have both oak fences and trapdoors, for example. I
Okay.
have multiple items in single chests. That's also the beauty of encoded chest hull, that you don't need separate MIS. You can have everything in chest hull. You could also have extra logic to put unstackables in here, but I did not want to do that.
Soon.
Yeah. So after building this, I realized that MIS in chest hull is not that nice. First of all, because if you want to do paralogic, it's weird. My paralogic is if you lost a chromosome and did it, it's basically my paralogic. It doesn't work properly. Well, it works kind of, but sometimes, well, it doesn't lock the hopper, right? So sometimes you would input partial box into a slice, sometimes not. And I don't have extra temp for those items, so my paralogic is not fully functioning. But yeah, I think I would prefer just like one, sometimes maybe two items per slice, like per chest, and then have separate MIS for some items. Because of speed, like you would have less boxes to process for chest holes, and also you don't really need everything in the chest hole, and you have to either duplicate chests or codes in the encoder, so it gets a bit annoying with swapping like item layout later. You have to remember which part of the encoder has duplicate codes. I mean,
Yeah.
you can look at the code layout and find out, but preferably you would just use it originally as it is, right? Yeah. It's mainly an issue if you have like 16 items in a single chest. I don't remember where I have that, because I don't have I have banners with candles, and yeah. It was for maybe carpets or something. I don't know.
So the ST2 event is happening in less than 10 minutes. So if anyone has like last questions or something, we could wrap this up.
Hello?
Hello?
Oh, okay. It's probably not going to be public, but are you planning on making it public, or is it going to be a gate capped?
This storage or
Yeah, the storage.
It is public.
this is public? I have a thread on Storage Tech Discord with the most recent version, so you can download it, look at it in survival yourself if you want to. We can link that, I guess, over here.
It's also on Soon CMP as well, which is
Well,
where-
yeah, we are on Sun CMP right now,
Yeah.
Oh,
but I can link the thread. Copy link. In text for voice, there's a thread for it. There is a download, a direct word download there.
yeah, thank you.
No problem. Yeah, I don't believe in gatekeeping. Like I believe in open source and everything. So that's also why I did this storage. I wanted to maybe more people being able to start working on encoded stuff, having some reference points. Like mainly with like chest hull processing, because that's like we have a lot of chest hulls published, right? We have codebox makers and stuff, but encoders and everything. I'm yet to see another fully working public example of that. Well, I guess you have it on SunCMP, kind of, right? But that's the other one I know of.
Just to ask, what's like the next event? Like Willie said.
Oh, MISUI.
Who's going to do that?
Christone and Tiz, I think.
Oh, okay.
Yeah, I guess so. If there are no further questions, we can wrap this up. So thank you guys for coming, asking questions, and thank you for having me over here, being able to talk about my storage, have a little discussion, explaining some stuff. It was fun.
Thank you for showing it, dude.
Yeah, no worries. When I make another one, it will also be public, so hopefully it will be better. And I guess we can move to storage tech 2 for the MIS discussion.
Awesome. Okay.